Welcome to this video lecture on StackADT and its implementation. Before we get started, let's quickly review some basic concepts to build a strong foundation. Look at this picture. The books are stored like this. Actually, they are dumped. Now I need to find a book title, A Tale of Two Cities. Just think, how is it even possible to find it in this mess? It's really a tedious job. Now take a look at this picture. Here the books are neatly arranged. Don't you think it's much easier to find the book now compared to the earlier messy one, right? So from the two pictures, we can understand the importance of organizing things properly. Just like organizing physical items, in programming, we also need to organize data for efficient usage. And that's where data structure comes into play. So what is data structure? It is a way of storing and organizing data that helps in efficient usage and management. Data structure are generally classified into two types, linear data structure and nonlinear data structure. Let's take a quick look at what each of this means. Linear data structure. It stores elements in sequence one after the other. Examples for linear data structures are arrays. The elements are stored in a contiguous memory location and each element is associated with an index. We can relate an array with the bank locker system in which each locker is associated with a unique number. The next example is linked list. Here the elements are stored in nodes where each node has a pointer that connects to the next node. We can imagine linked list like train compartments in which each compartment is connected to a next one. Next example is stack. In this data structure, elements are inserted and removed from the same end. We can say it as top of the stack. A good real-time example for this stack is stack of coins. Next linear data structure is queue. Here insertion takes place at one end and deletions take place at other end. We can relate it with a line of people standing in a ticket counter. The one who arrives first will be served first. So that is the queue concept. It follows the principle FIFO, first in, first out. Next one is non-linear data structure. The elements aren't arranged in sequence. Instead, they are either stored in a hierarchical or in an interconnected way. Example for nonlinear data structure is tree, where elements are arranged in a hierarchical manner. It starts with a root node and branches out to child nodes, forming a structure like an inverted tree. We can relate the folder structure on our computer with tree. It starts with the main folder, which contains subfolders and files, where the subfolders can also have their own subfolders and so on. The next example for nonlinear data structure is graph. It consists of nodes, also called as vertices. They are connected to other nodes using the edge. We can compare graph with cities connected by roads. Now let's focus on our topic, StackADT. What exactly is StackADT? It is a mathematical model which describes how the data is organized and the operation that can be performed on it. Since it hides the internal implementation and only defines what operations are allowed, so it is referred to as abstract data type. The stack operates on the principle last in first out in simple LIFO. The item that is added last will be the first one to be removed. In stack, both insertion and deletion takes place at the same end, which is tracked using a pointer called top. The pointer always points to the most recently added element. Let's take a look at the basic operations associated with the stack. Push. To insert an element into the stack, we have to perform the push operation. Next one is pop. This removes the topmost element from the stack. Pick. This allows us to read the topmost element without removing it. Next operation is empty. It is used to check whether the stack is empty before doing pop operation. Similarly, is full is an operation used in the array-based stack implementation. Since it is of fixed size, we have to check whether the stack is full before pushing an item into the stack to avoid the overflow errors. Let us understand the concept of stack by using this simple demonstration. In this demonstration, we have to perform the stacking of books. Consider this as a box in which only one end is open, because we are going to perform both insertion and deletion operation in the same end. The operations associated with the stack are push, pop, peek, is empty, is full. To insert an element in the stack, we have to perform the push operation. The top pointer always points the topmost element in the stack. When we perform push operation, the top pointer will be incremented. To remove an element from the stack, we have to perform the pop operation. Pop operation remove the topmost element in the stack because stack follow the principle of last in first out. The last inserted element is likely to be removed first. Peek operation reads the topmost element in the stack without removing it. Is empty method is used to check whether there is an element in the stack. Now there is no element in the stack. If we perform a pop operation, it will throw an error. Since there is no element in the stack, we cannot perform the pop operation. During this time, we have to use the isEmpty method to avoid this type of error. Next one is isFull method to check whether there is a space in the stack to insert an element. So now the stack is full. If we try to insert an element in the stack when there is no space, it will cause the overflow error. To avoid this, whenever we perform the push operation, we have to check whether there is a space in the stack to avoid the overflow error. From this demonstration, we can clearly understand the concept of stack, how the data is organized in a stack, and the operations that can be performed on the stack. Since it hides the internal implementation and it defines only the operations allowed on it, like when we press the push button, the element is added. When we press the pop button, the element is deleted. But the internal implementation is hidden from us. It is referred to as abstract data type. Since a stack is an abstract data type, it needs to be implemented to make it work. There are two ways to implement this concept, using an array and using a linked list. An array is a collection of elements stored in contiguous memory location where each element is accessed using an index. In a linked list, there is a sequence of nodes where each node contains a data and a reference to the next node in the sequence. The last node contains the value null. So this is about array and linked list view. Both methods have their own advantages and disadvantages. Now let's look at each method and understand its implementation through pseudocode, which you can later convert in any programming language as per your preference. To implement the stack concept using array, first we have to create an empty array named stack with a fixed size. As we know, array indices usually start from 0 to n minus 1. In our case, we have created an array of size 5, so our indices ranges from 0 to 4. Next, in our stack, we are having one pointer called top, which always points to the topmost element in the stack. In our array implementation, the top pointer always denotes the index value. So in an empty stack, the value of top pointer is -1. So to perform push operation, first we have to check whether there is a space in the stack. So for that we are checking our value of top pointer. If it reaches maximum size, the value of the top pointer is maximum size. In our case, if it is 4, already our stack is full. So we simply print the value of stack as full. Else we have to increment our top pointer, then we have to add the element in that index. So like this, first we have to increment our top pointer, then we are going to add the element in that index. So in our index is 0, so our element is added. So in push operation, we have to increment our top pointer to insert our element. So next we will see the routine for the pop operation. To perform pop operation, we first check whether our stack has an element. In an empty element, we could not perform the pop operation. So for that, we are checking the value of top. So if the value of top is -1, it denotes that our stack is empty. So we simply print stack is empty. Else, we have to store our value in temporary variable for later use. Then we have to decrement our top pointer. So like this. So next operation in our stack is peek, which is used to read the topmost element in the stack without removing it. So to perform peek operation, first we have to check whether there is an element in our stack. If our stack is empty, we simply print stack is empty, else we print the topmost element. So stack of top, the topmost element value will be printed. Next operation is empty. If our top value is -1, it denotes our stack is empty, so it returns true value. If else, it returns false value. Similarly, to check whether our stack is full, first we have to check the top pointer. If it reaches maximum value, it returns true, else returns false. So these are about the implementation of stack using array. From what we have understood about the array-based implementation, the advantages are that it's simple to implement and we can access element quickly using their indices. But the problem is the size is fixed when we create the array. If we don't use all the spaces, memory gets wasted, and if we need more space later, we can't increase the size. So when the stack is full and we try to add more items, then overflow happens. Next we come to implementation of stack using linked list. So we know that in linked list there is a structure called node. So in a node we have two fields, one is data field, another one is next field. This next field points to the next node in the linked list. So before going for implementation, this is the structure of node. Two fields, data field, next field points to the next element. So first we have to create our top pointer in an empty stack. The top pointer value is null since there is no element in the stack. So like this, our top pointer points to null value, indicates that our stack is empty. To perform push operation, first we have to create a new node with data and next field. So when I create new node, it created with two fields. In the data field, we have to add an item. So for accessing that, we have to use new node data equal to item. Then we have to insert that item. Then in the next step, we have to change the value of next field to the value of top. So since our top points to null, the value of next field changes to null. After that, we have to update the top pointer to the new node. So top pointer points to the new node. One more push operation. First step, we have to create the new node. Second step, we have to insert the item. Third step, in the new node next field, have to point the value pointed by top pointer. The last step, we have to update the top pointer value to the new node. First, we have to create the new node. Then we have to add the item. Then next field points to the top pointer value. Then our top pointer points to the new node. So these are the steps we have to follow in the push operation. Next one is pop operation. Before performing the pop operation, we have to check whether our stack has an element. If there is no element, we have to simply print stack is empty. So for checking that, we have to check our top pointer value. If it is null, our stack is empty. Else, first we have to create a pointer called temp, and it has to point to the node referred by the top pointer. Then in the next step, have to store the data pointed by top pointer in a temporary variable. Then we have to update our top pointer to the node pointed by this topmost pointer like this. This reference is changed to the next node. After that, we have to delete the temp node like this. So these are the routine for pop operation. Next operation is pick. To read the topmost value, first we have to check whether there is an element in the stack. If the stack is empty, we print it as empty. Else, we will print the top value as by referring it as top.data. To check whether it is empty, we have to check the value of top. If it is null, then this function returns true, else it returns false. There is no need for useful routine linked list because it is dynamic, so size can vary according to our requirements. From what we have learned about the linked list based implementation, one big advantage is its dynamic nature. The size can grow or shrink as needed, so there is no memory wastage and no overflow problem. But on the downside, it's bit more complex to implement because we have to create node with reference to the next node. Also, extra memory is needed to store these references, which makes it a bit slower than the array based implementation. So I hope this video helped you to understand the stack concept and how it can be implemented. Thanks for watching patiently.